Hello, in this video, I will show you how to train your own classifier. So you won't be using any pre-built packages, you will train your own one to make predictions. So let's read in the train dataset and let's have a look at what the train dataset looks like. So it's very simple. It has a ID, which is a unique identifier for each row. You have the text that we want to predict the sentiment for, and then we have the sentiments here under the sentiment column. And sometimes there are text fields which are blank or which are filled with null values, and I'm just going to drop them here. So as you can see, it's drop NA. So I'm just dropping the rows where the text is null. So I mean, if there's nothing, then we don't really need to predict sentiments for nothing, right? So that's why I'm doing that. And okay, so just a word about this. When we train our own classifier, we need to do a little bit more pre-processing than we need to do for when we need to use the pre-built package. Because pre-built packages are very powerful, you don't really need to do too much cleaning. You just throw it a bunch of text and it can give you a sentiment score. But if we are training our own model, then we do need to do a little bit more cleaning and pre-processing. That's why I need to remove punctuations here. And how do we do that? Again, we use regular expressions. So what this regular expression shows is basically we want to find something which is not an alphanumeric character and something which is not a space. So this symbol here means not, is the negation symbol, okay? So it means not. So we're looking for something which is not an alphanumeric character and not a space. And we are replacing that with nothing. So we're basically removing it. So this piece of regular expression will look for all punctuations, well, basically all those symbols, and remove it. So if we just do that, and then we can have a look at again what the first text piece looks like. And you can see now that it looks pretty much the same, but the comma has been removed. And we do need to remove it when we're training our own classifier. And then next, what we want to remove are stop words. So again, I've explained that before. Stop words are commonly occurring English words like is, the, that kind of stuff, which again, we can't really use to infer the sentiments of a piece of text from. So because they're useless, we remove them. And we're just going to import the stop words. And then we're going to specify the language, which is English. And then there's the lambda function again. And this looks, a bit complicated, but basically we're going through each of the text and removing any word that is deemed to be a stop word. And it does take a while. So if we want to have a look now, you can see that a whole bunch of stuff have been removed. So for example, have, that's a stop word, and if and I, they're all stop words. They have all been removed. And why are they removed? Because, well, as I've explained, you can't really infer whether the text is positive or negative based on these commonly occurring words. Okay. So the next part, we want to remove the links. Now, this is something we've done in the previous video, so that's why this piece of regular expression looks very similar, very familiar. And to be honest, it's exactly the same, okay? So I don't think I need to explain too much here. And then the next part is stemming and lemmatization. Now, these might seem to be long words, but what they basically both do is they normalize the word. And if I just quickly run through some examples, you'll find out what normalizing the word actually means. So I'm just going to import the necessary packages. And then let's have a look at the sentence here. So this, well, text has woman, running, runs, ran. So we can kind of already tell that run and running and runs and ran, they kind of belong, they kind of have the same meaning. They're just, some is a past tense and then there's a plural here, and they're pretty much the same word and have the same meaning. And when we train our own classifier, um, if we don't normalize these four words, then they all will be treated as different words. And it's unlikely that, the plural of run or the past tense of run will have a different effect on the sentiments of the text, because essentially they're all the same word. So that's why we want to normalize it so that they are all treated as the same word. So if we just have a look at what this does. So what this Porter stemmer is going to do is stemming transformation of the text. So what stemming does, as you see, is the first three instances have been converted into run, while the last one remains as ran. And what is actually happening is here is stemming actually chops off the word, right? So run remains run, running has been chopped off here, so the ing has been chopped off and it's only returning run. Runs again is the s has been chopped off, so it's returning run, but there's nothing to chop off here, so it returns ran. So maybe that will give you some intuition into how stemming actually works. It basically chops it off and tries to find a common word which links them together. That might not seem very powerful, but then there's another way to do it, and it's called Limitization. So again, if I just run this, you can have a look at what happens. So Limitization, as you can see, doesn't do any it doesn't work by chopping off things. So Limitization works a little bit differently from stemming. It has a lexical database, and where it can look up the words, and then it will try to find the base form of the word. So it seems like the base form of the past tense of run remains ran, but they successfully, kind of successfully converted the plural form of run to run. So usually lemmatization is better than stemming, because stemming is rather crude. It kind of just chops off the end of the words, and sometimes the results are rather unpredictable. In this instance, stemming seems to be better, but in general, lemmatization is more powerful. But you can choose which one to use. You can run a few examples with it and then make a decision yourself. So this piece of code here, again, that's the lambda function, which you should be familiar with from phase one. And I'm just using the lemmatizer to lemmatize each piece of text in the data frame. Yes, so now we will move on to training our own classifier for sentiment prediction. I will import some packages from scikit-learn. And I will again read in the data. And you can see here that I'm only selecting the first two rows because this is just a demonstration, and I just really want to show you oh, hold on, oops. And I just really want to show you a bit later on what the feature matrix looks like. Visualizing the features matrix is a bit hard when we are doing it over 20,000 rows or something like that. but doing it with 2 rows is very easy, and it will give you an immediate understanding of what is actually happening. When you do train your own model, you won't need to visualize the features matrix. I'm only doing it here so that you get an understanding of what's going on. Okay, so we're going to get the count factorizer function. And what does count factorizer function is it creates the feature matrix. So it transforms some text into a training matrix, which we use for machine learning. And I'm going to use it here. This is the factorizer, and I'm going to do a fit transform function on the text. So I'm just going to change this to sample. So the sample is the first 2 rows of the data frame, and I'm just going to fit transform the first 2 rows, and then I will show you what it looks like, and then you should, immediately be clear about what's going on. There we go. So this is what the features matrix is, okay? So as you can see, each column is a feature. Just like when you're doing machine learning normally, each column is an attribute. For example, in phase 1, column 1 might be the number of rooms of the property. Column 2 might be the number of rooms, number of bathrooms, or the number of the population in the area of the property. And feature 3 might be the income status of the property. So each column is a single feature, and as you can see, each word represents a single feature. So if we just have a look quickly now, I'll just do this. Okay, so we have the first row. So this is the first row. They have going, they have, and they have if. So that's why they have ones there, because the word going is over here, the word if is over here, and the word responded is over here. So as 1 means that this feature is present, and 0 obviously means the feature is not present. So this here is the training matrix which we will use for machine learning. So from this point on, it should be quite straightforward and clear what's going on, right? I mean, you have the matrix, and you have your y values, which is the sentiment column, and you're just going to run a scikit-learn package over this matrix just like normal. So once you apply the count factorizer function to the text and got the features matrix, it's just machine learning as usual. Nothing new here. We're going to use the multinomial naive Bayes model. You can also use something called the Gaussian naive Bayes. But just for demonstration, I will stick with this one here. Okay, so again, you're probably quite used to this because you've done it in phase 1, and some of you have done it in your personal projects. We're just fitting the model, right? And we're fitting x, and x is the feature matrix, and the second parameter is the y values, is the item we want to predict. So what are we trying to predict? We're trying to predict the sentiments. So I put sample sentiments here. And that's it. That's all you need to worry about when you train your own model. Now, when you do the testing, you need to apply the same transformation that you applied. So what that means is all those cleaning, okay? So all these stemming and pre-processing and stop words and whatever, you need to apply the same steps to the training set. And also, you need to apply the count factorizer to the testing set as well. That's because we need the features matrix to be the same for the testing data in order for us to generate sentiments for it. So the columns need to be the same because this model, this multinomial naive Bayes model, has been learning. Okay, so it learned from this data frame, this features matrix. So when we do the testing set, you need to create the exact same feature matrix for the testing set so that this model can recognize it and generate predictions for it. I didn't cover that part because if I did, then I'm basically doing the whole, the Kaggle challenge for you. So I'm just going to leave that as an exercise. But again, there's nothing new here, right? We instantiate the model, we fit it, and then we run it, calling the predict function to run it over the testing set, and then we generate predictions. And then once you have generated the predictions, you can just use the accuracy score, which I think you guys have used in phase one, to look at what the accuracy is. That is actually all for now for this video. If there's anything you don't understand or confusing, obviously you can just ask on what is that called? Discord, and then one of us will reply to you. But I really didn't cover the testing part because, yes, as I said, I'll be doing all the work for you otherwise. Thanks.